So, transformations of function graphs. Now, we started off with all this stuff last week, right? We did horizontal shift, we did vertical shift. Yes? What letter represents the horizontal shift? H. H for horizontal, right? K gives us our vertical, yes? Positive K means move up, negative K means move down. Positive H, which actually tricky looks like a negative H in the equation, but positive H is a shift to the right, and negative H, which looks like a plus in the equation, means shift to the left. Today we're going to focus on what do A and B do. All right. Now B actually does a lot more than what we're going to talk about today, but we're only going to cover one aspect of B because B gets really funky. Okay, when it gets, yeah, we're just going to keep it simple. All right. So, if you look at my three equations right here, what letter do you think we're focusing on first? A. A comes before f of x. Comes before the f. In my equation from over here, you can see it's still before the f. Yeah? I'm going to do all sorts of colors here today, so just be prepared for Technicolor notes. So, here's my first equation. G of x equals 3 times f of x. So what does that mean? That means that I am going to keep all of the x values the same as the original ones. So 0, comma something, 2, comma something, 4, comma something, negative 2, comma something, and 5, comma something. And what it's saying is to find my new y value, which is g of x, take 3 and multiply it by the old y value. So the old y value here is 0. 0 times 3 is 0. Old y value is negative 2. Multiply by 3, new y value is negative 6. Old y value is 0. Multiply by 3 is 0. Old y value is 2. Multiply by 3 is 6. And old y value is 1. Multiply by 3 is 3. These are the points that make up the graph of g of x equals 3 times f of x. So let's plot those points. You ready? 0, 0, 2, negative 6, it's down there, 4, 0, it's right there, negative 2, 6, and then 5, 3. Okay? Now, this looks like it's the end of the graph there. This comes up, and I'm assuming it's going to keep going because I don't know where this point ended up.
Can I get the number here, Brady?
Yes, right there. So this is going to keep going, and eventually it'll stop once it's this far out. Okay. What happened? It got bigger. How? Don't know how to say it yet. Let's do the next one and see if it's easier to say. Okay. Let's now do 1/2 times f of x. So again, I'm going to keep the same x values. I have 0, comma something, 2, comma something. I know this green's a little hard to read, but I'll try and do it as dark as I can. 4 something, negative 2 something, and 5 something. And then what am I going to do to the y values this time? Multiply them by 1/2. So the original y value was 0 times 1/2 is still 0. Original y value was negative 2. Multiplied by 1/2 is what? Negative 1. Original y value was 0. Multiplied by 1/2 is still 0. Original y value was 2. Multiplied by 1/2 is 1. And original y value was 1. Multiplied by 1/2 is 1/2. So let's plot those points. Now, she gave me 3 graphs, so I'm going to plot this one on the second graph here. So I'm not graphing on top of everything. You ready? 0, 0, 2, -1, 4, 0, -2, 1, and 5, 1/2. Now, I'm going to be very careful how I draw this in because my graph ends here, and it's got to end here also because that's where this one ends. So it's going to go this way all the way till about there. And then it's going to stop. Why did I stop it there? Because that's where it stops there on the original graph. I can't make it any wider than the original graph. What did that do to it? What did the 1/2 do to it? Made it wider. But if I look at this, is it really wider? If it starts and ends at the same place, is it really wider? Left to right? So I don't think wider is the right word that you're looking for. Because it still goes from, looks like -2 to +11. So what could maybe be different than wider? Anybody? Nobody. Okay. How is the first graph, the pink graph, different than the green graph? Words, people, words. Yes.
It's compressed.
It's compressed. What do you mean by compressed? Which one is compressed? The pink one is compressed?
Yeah,
Okay, in what way?
I guess just the lines of
Like it's been squished together a little bit? Okay. You're on the right idea. However, the pink one has not been compressed. The green one is actually the one that has been compressed. It has been compressed, what we say, vertically. In other words, left to right, it's still the same width. But what happens is, it looks like a fat guy sat on it. Right? That's what compressed is. Okay, that's what vertically compressed is. If I think about, here's a hair tie. Okay? If I think about these two ends being here, these two ends not moving whatsoever, if I leave them there, if I stretch it, it becomes taller, and it looks skinnier, doesn't it? It looks bigger, but it's the same hair tie. So what we're doing is we are vertically stretching it, or we are vertically compressing it. That's a little bit harder to show, but if I were to squish it down a little bit, that would be compressing it. Okay? So we are vertically stretching or compressing. Let's see what this one does. How is this one different? It's a negative, so let's see what the negative is going to do to it. I'll graph that one on the bottom graph there. So again, my x values stay the same. 0, 2, 4, -2, and 5. But what am I going to do to the y value? Multiply by -1. So 0 times -1 is 0. -2 times -1 is +2. 0 times -1 is 0. 2 times -1 is -2. And 1 times -1 is -1. So let's graph that on the third graph over here. 0, 0, 2, 2. Gosh, that makes me feel like I did something wrong because that point is right in the middle. 4, 0, -2, -2, and then 5, -1. So what I have here is what? It's upside down. Is it any narrower? Like left to right? It's still the same size, left to right. In fact, it still seems to be the same size up and down even. Right? If I were to look at this, it looks like it goes up 4/4, and this one right here goes down 4/4. So it looks like it's the same size. It's just been flipped upside down. So what that tells me is that A can do 3 different things. It can stretch vertically, it can compress vertically, or it can reflect vertically. All right? So let's label this here. So when we had an A value of 3. We had a vertical stretch of 3. In other words, we basically make, it ends up being 3 times as tall as the original one. Same width, but 3 times as tall. When A was 1/2, what do we have? A vertical, not a stretch, but a compression of what? 1/2. That means it's half as tall as the original. Same width, but half as tall. And then finally, when A was -1, what did we have? A vertical reflection. Now, sometimes you will hear a vertical reflection or any kind of reflection referred to as a reflection over a certain axis, either the x-axis or the y-axis. If you look at the graph of this one down here, would you say that is reflected over the x-axis or over the y-axis? X-axis, because it has gone from upside or right side up, and it is literally flipped down like that, right? So vertical reflection over the x-axis. Okay? So what if I needed to write a function that represented f of x stretched vertically by 3/2? Now, let me step back for a minute, because what was the difference between what gave me a stretch versus what gave me a compression? Because when this was 1, it didn't give me any stretch or compression. It just flipped because of the negative. So in other words, a 1 does not stretch or compress. What was it about these two numbers that made one a stretch and one a compression? Yeah. Higher than 1 or lower than 1. I'm going to be a little bit more specific because that's correct, but I want to make sure we're in the same place. Bigger than 1, absolutely. It could also be less than -1, because you could have A equaling -3, and it's still a stretch, but it's a stretch with a reflection. Okay? You could also have A equaling -1/2, which is technically less than 1. And it would also be a reflection as well as a compression. So we've got to get a little more specific. We say that A is our vertical change. When A is bigger than 1, we have a vertical stretch of A, whatever A is. Vertical stretch of 3 or whatever A is. When A is between 0 and 1, we have what? A vertical compression of A, meaning it has vertically been squished. And when A is less than 0, and it could be in combination with either of the other two, what do we have? Less than 0 means negative. We have a vertical reflection. So those are the 3 things. Now, some people like to think, oh, if it's a fraction, that automatically makes it a compression. Not true. Because A is only a compression if it is between 0 and 1. Are all fractions between 0 and 1? No. Right here is a fraction that is not between 0 and 1, which is why it says it's a stretch. So don't get stuck with that fraction equals compression. It's all about what does that fraction represent. So if I were to write a function, g of x is equal to, how would I write my equation if I wanted to show f of x stretched vertically by 3/2? Well, I need to make an a value of 3/2, and then I have f of x. That's what my function would look like. Okay? Questions there? Yes? No? All right, let's turn to the back side. So that was our A information. Now we're going to move on to our B information. Now there's actually a little typo here. I'm going to white this out. We are not doing a horizontal stretch by 2. We are not doing horizontal stretches and compressions. And I'm going to change that to reflect over the y-axis. Now think about that for a minute. Is that a vertical reflection or a horizontal reflection? If I'm reflecting over the y-axis, my y-axis goes vertical, right? But the actual reflection is not vertical because the reflection moves something from the right to the left or from the left to the right. So the reflection itself is actually a horizontal reflection. Yes? Does that make sense? Now, I'm going to show you two different ways to do this. All right? The first way I'm going to do it is I'm just going to go straight to the graph. When I do a reflection across a y-axis, here's what I do. I take each of these points, I find out how far it is from the y-axis, and then I just go that same distance on the other side of the y-axis. So this one is, it's funny, it's got all these grid lines, but it's actually at -1. Yeah, it's 1 unit to the left of the y-axis. Its new home is going to be 1 unit to the right of the y-axis. Does that make sense? 0, 0. It's not, it's on the y-axis, so its new home is going to still be on the y-axis. This point right here, it's 1 unit away from the y-axis on the right. So where's its new home going to be? 1 unit to the left of the y-axis. Kind of makes sense? And then this point is 1, 2, 3 units to the right of the y-axis. So where's its new home going to be? 3 units to the left of the y-axis. And when I connect those lines, or connect those points, I should say, I have my reflection. I've flipped it around. What if it was a reflection over the x-axis? What would I do? Same thing, I would just judge how far is it above the x-axis and then move it to below the x-axis, or vice versa, below the x-axis to above. That would be a vertical reaction or reflection. How does that look with points? Well, you can do it with points also. When you have a reflection over the y-axis, all you do is you change your x value to the opposite sign. So -1 would become a +1. 0 doesn't have a sign to change. 1 would become -1. 3 would become -3. And let's see if those points match up with my graph here. 1, 2, there's that one. 0, 0, -1, 1, and -3, -1. It does match up. Now, on the other side, I was changing y values. Why am I changing the x values here? Because I've got an equation like this, which means what I've been dealing with here is a b value of -1. Okay, so this, if I were to put g of x right there, that's actually the equation I was dealing with here. A little bit different. So when we have, this shouldn't say f of x equals 1 over bx, it should just say f of bx, because this is our number we're looking at. We are only going to see that b value. It's either not going to be there, meaning it's 1, or it's going to be -1, meaning we have a horizontal reflection when we have it less than 1 or equal to 0. We're not going to do b as -3 because horizontal stretches and compressions are a bit confusing. So if I were to come back to this right here, let's add in what we know now. We know that A is a what? It's vertical, right? It's a vertical stretch if A is greater than 1. It's a vertical compression if A is between 0 and 1. And it's a vertical reflection if A is less than 0, or in other words, if it's negative. All right, what about B? What did we just learn about B? If B is less than 0, meaning that it's negative, what does that mean? We have a horizontal what? reflection. Okay, so. All right, let's go finish off these notes then. So, describe how the graph of this nasty equation is different from f of x. So when it says describe, here's what I want you to do. I want you to take each of the letters, the A, the B, the H, and the K, and tell me what it's doing to the original graph. So in other words, I have A, B, H, and K, right? So I notice that A is -2. What does a -2 for an A value tell me? Well, if I come back here, A is greater than 1 because it's 2, right? So I have a stretch of 2, but I also have a reflection because it's negative. Yes? Do you see that? So because of A being -2, I have a vertical reflection and stretch of 2. Make sense? Now let's see what B does. So B is -1. What does that tell me? I have a horizontal reflection. All right, let's talk about our H value. Our H value looks like a +1 right there. But what does that tell me H actually is? -1. So I have a shift how? Left 1. And then finally K is -10. So what does that tell me? Shift down 10. That's what I want to see when you see the instructions say describe. Okay. Now, if it doesn't have an A or a B, your description's only going to be these 2 bullets, right? But this is how I want to see it when it asks to describe. Does that make sense? Okay. Last problem. Function f of x is shown as a solid black line. So this is f of x. Find the equation of the dotted line g of x in terms of f of x. So the first thing I always look at is there any kind of dimension change? Meaning, does it look like it has shrunk or grown at all? Or does it just look like it's been moved around? Does this look any smaller or bigger than this guy? No, it's just been moved. All right, that gives me somewhere to go with that. How has it been moved? Well, first off, I notice it's backwards, isn't it? This one, if it's almost like a check mark to the left, this one's now a check mark to the right. So what movement would that be? Is that a shift? It's a reflection, isn't it, if it's going backwards now? What kind of reflection, horizontal or vertical? If it's going from left to right, that's a horizontal shift, or a horizontal reflection, sorry. Which letter tells me a horizontal reflection from my equation? A, B, H, or K? B. So that means I have a B value of -1. I should have written this down, but I didn't. What is my A value? If there's no stretch or compressing, because it's all the same size, my A value, it's not 0, I have to call it 1. Because if I had 0, since A is multiplying at the beginning of the equation, 0 times all that would just make it all drop out. So it's just got to be 1, meaning that it's the same size. All right. Now, it has not only been flipped, it's also been moved. So how could I find out how it's moved? Well, I'm going to pick a point. To me, there's only one logical point to pick, right? What point would you pick? The thing that looks like a vertex, kind of, and see where it ended up. So it looks like I can go either left to right first or up and down, doesn't matter. I'm going to go up and down, 1, 2, 3, 4 down. What letter does that affect? That means I have a k value of what? -4. And then there's also 1, 2, 3, 4 to the right. What letter does that affect? H. What's my H value? +4. So now I just need to put that information into that equation. So A comes first. A is 1, so I don't need to write it. And then I have f of B, and then, sorry, you can't see that, B, and then parentheses x minus h. So B is -1, and then another parentheses for x minus h. Well, h is 4, so it's going to look like -4 in my equation. Close both those parentheses. And then k is also -4, so that just goes there at the bottom. And that's what the equation should look like. Okay? So? Yes?
Wouldn't there be no horizontal shift because of the horizontal reflection? Because that would move the vertex over 2. Right?
Good question. Hang on. Horizontal shift. I'm sorry, horizontal reflection. Since it's over 2, it would be over 2. You're right. There is no horizontal movement. My bad. So we don't have an h value. So it would just be -1 times x in there. Do you see why that is? Because in the step of reflecting, it's already going to be looking like that. And so it's literally just moving down. Thank you for that. I was treating it as though this was on the axis, and it wasn't. Okay? Thank you for that correction. All right. Your homework is out of the textbook, but because we know you guys don't like opening your textbook, we actually printed it out on paper. You're welcome. There are a couple questions where we changed the instructions on, so if you actually look at the textbook, which I doubt you will, you'll notice the instructions are different on this paper than they are in the textbook. Okay? Happy studying.